For example 3, it says if an open-top box with a square base is to be constructed with 2,700 centimeters squared of material. Well, centimeters squared is going to be my surface area. What is the largest possible volume? We also know that it has a square base. So once again, I'm going to start with step 2, and I'm going to figure out what this looks like. So I have a square base. And then it is an open top box. Well, if the base is square, then the side lengths on the base have to be the same. But it doesn't mean that the height has to be the same. So what are we going to say? We're going to say that we're going to let x equal the side length of base. We're going to let h be the height of the box. And v is going to be the volume of the box. And all these things have to be greater than 0. Now, we know that volume is equal to length times width times height. But in this case, the box is a square, which means that this would just be x times h, or x squared times h. When I get to step 4, I need to eliminate one of these variables. Well, this is where our surface area comes in. Our surface area is equal to the base of the box, x times x, and then the 4 sides of the box, because it's an open top, 4 times x times the height. Which means that if 2,700 is equal to x squared plus 4x times h, then 2,700 minus x squared is going to equal 4x times h, which means that h is going to equal 2,700 minus x squared, all divided by 4x. And we're going to put that back into our formula. We're going to say that the volume max is going to be based on x squared times the height, or x squared times 2,700 minus x squared all over 4x. And we're going to simplify this. We're going to take away an x from the numerator and the denominator. We're going to expand that x out, the remaining x, and get 2,700 minus x cubed over 4. Sorry, 2,700x minus x cubed. Don't forget the x there. And then from there, I'm going to simplify this. And I'm going to say that, well, the 2700 is divisible by 4, so I have 675x. And minus x cubed over 4 is just going to be 1 over 4 x cubed. When I get to step 5, I have to derive. So v prime of x is just going to equal 675 minus 3 over 4 x squareds. When I get to step 6, I'm going to do the critical numbers. So if 0 is equal to 675 minus 3 over 4 x squared, then that means that 3 over 4 x squared is equal to 675. And when I multiply by 4 and divide by 3, then I get x squared is equal to 900. When I square root both sides, technically I should take the positive and negative square root and say that's the positive square root of 900 and the negative square root of 900. But we already said that it can't be a negative number, which means that it can only be the positive square root, which is 30, because x has to be greater than 0, like we already stated. We're going to do our first derivative test. And we're going to pick a number in here, so say 1 and 40. And we take v prime of x. When I sub in 1, I get a positive number. When I sub in 40, I get a negative number, which means that the v of x is going to be increasing and then decreasing, and this is going to be a max. So if I have a maximum of 30 and it wants to know what is the largest possible volume, we're just going to take the formula where we simplify the volume. If the volume is equal to 675 times x minus 1 over 4 x cubed, then I'm going to say that it's going to be 675 times 30 minus 1 over 4 times 30 cubed, which means the volume is going to equal 13,500 centimeters cubed. Therefore, the largest possible volume of the open top box is 13,500 centimeters cubed.